And then we come to another topic. In the simulation job, you have to specify what output you want to write to file. If you come to this page, usually you have some default selected variables here. And here I have clicked the clear button, so it disappears. And also you need to care about the interval in which the data is written out. The default is rather infrequent one, 3 hours. Probably you have your I/O computational I/O resources, you can spend it. So you can specify it to do 1 hour or half an hour, something like that. And then you change it to be more frequent. The number of time slices will be multiplied. And then you will see that the data size will become larger. But usually this is not the bottleneck. And usually you can write what you want to your storage. And then there are a lot of variables to choose. So what are they? First of all, I need to introduce 2 adjectives. One is prognostic, the other diagnostic. Prognostic variables are those variables that are simulated basically in the model. The rate of change of these variables are formulated in the model and usually in the dynamic core. And some physics parameterization scheme will introduce more variables as prognostic variables. And then the time evolution of this variable is to be calculated. So take the example that I told in lecture 1. Density is one example of prognostic variable, and temperature in the form of moist potential temperature is another prognostic variable. And also by density, it is actually transformed to a variable called rho cc, dry air density divided by something something. So usually in numerical algorithms, the implementer have higher mathematical skills and try to transform the mathematical problem to some way that is more efficient to carry out the computation. And then what is an diagnostic variable? It is a variable that can be calculated by other prognostic variables. Take this example, we have the ideal gas law. So given density, rho is simulated, and temperature is simulated, and then the gas constant is a constant. This ideal gas law will determine the pressure. So you don't actually need a partial differential equation to describe the change of pressure. It is already here constrained by this ideal gas law. So if you specify the program to output variables related to pressure, just like in this search box, you can enter pressure, and then our web interface will search output variables that are related to pressure, and then you will see these variables names and the description of the variables. But you can see that they are in the group DIAG. That means they are diagnostic. And for the search about density and temperature, you will see that it is in the group state. That means it is in the group of atmospheric state, and they are prognostic variables. And so this is also in the state group. So it is just for convenience for the program to carry out such calculation from other prognostic variables and then write the calculated variables to the output NC file. So you can specify them by clicking a tag here if you want them to be written out. And then you can in Jupyter Notebook, you can open the data set, and then you will see these variables, and then you can do some plotting and analysis of whatever variables you put a tag there.